Hello, fellow students. Today we're going to start this lecture about paths. We're going to review all the basic concepts and put some examples. So stick around and enjoy yourselves. And well, this is the exercise that we have for today. We have this graph here on the right. As you can see, it has 5 nodes and several edges. And this is the question that we have, right? Define, if possible, the following kinds of paths given the graph in the picture. Justify otherwise, right? If you can't build the path. And the first question is a cycle of length 5. Okay, so the first step before doing this exercise is to review all the theory about paths, right? So we are going to define what is a cycle, an elemental path, and a simple path, right? Okay, so starting by elemental path, it is the path where all the vertices are different except the endpoints. Okay, so that means that there are no repeated vertices. Okay, so we create a path in the graph where all the vertices are different, except the endpoint, right? That can be the same as the starting node of the graph. The endpoints, right? So if it is closed, then the endpoint will be the same. Then we have a simple path, which is the path where all the edges are different, right? So there are no repeated edges. So as you can see, it's more or less the same thing, but with the edges except instead of the nodes. And then we have a cycle, which is a closed elemental and simple path, right? So that means that if it is closed, that means that the first node is the same as the final node, and we have a number of nodes greater than 0. So we have at least one node, right? So it will be like this. So we can start with the question, right? Once that we have reviewed all the basic concepts. So let's put an example of a cycle of length 5, right? It means that we will need 5 nodes in the path. So we can start, for instance, by the node 5, right? We take the edge C, we go to the node 2, Then we take the edge D and we go to the node 4. In 4 we take I and we go to 3. In 3 we take 8 and we go to 1. And this is already length 4, right? So finally we take A and we go to 5 again. So this is the initial node, which we will call B0. And this is the final node, right, which is 1, 2, 3, 0, 1, 2, 3, 4, 5, right? So this is B5. And we have also all the edges, 1, 2, 3, 4, 5, right? You have the 5 edges, so this is A5, right? And this is A1. So when we have a path of this kind, right, we are going to see one by one if it meets all the things that we are asked for, right? So it is a path, right? Because we have a starting node and we have a series of edges and a series of nodes, right? So it is a connected path. It is closed, right? Because the initial node is equals to the last node. So as you can see, we start in the node 5, and at the end, we end up in the node 5 again, right? So it is closed. It is simple because there aren't repeated nodes, right? Except the endpoint, but as we said, the endpoint is allowed. So it's 5, 2, 4, 3, 1, right? We don't repeat any node. We go 5, 2, 4, 3, 1, and 5, right? We don't repeat any node. Cycle. So it has to be elemental. Sorry. For simple, it is the edges, right? What it is not repeated. Okay. Anyway, it's more or less the same, right? You can see how here we have C, D, I, 8, A, right? All of them are no repeated edges, right? And now in elemental, it is elemental, right? So there are no repeated nodes, right? We have checked this before, and we are not repeating any node here, except except 5, which is the initial node and the final node. And it is simple, it is elemental, and it has length 5, right? Because we have 5 edges. So more or less we have proved, right? We have proved that this is a cycle of length 5, right? Because it meets all of these criteria. Okay, so the next question is a closed and simple path of length 9. Now you have to notice that as the length is 9, it cannot be elemental, right? We will need to repeat at least one node. So the thing that we must do is start by a node, like 5, for instance, and we need to start to build the path with a length of 9, right? But in this case, as it has to be simple, we must not repeat any edge, right? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have more than 9 edges, so we can do it, right? We must, should be able to do it, and we have no isolated nodes. We will need to repeat at least one node, right? So for instance, we can start but by 5 again. We go by 8 to 1. We go by 8 to 3. We go by I to 4. We go by E to 5 again, right? Now we can repeat nodes. We go by B to 1, and we can't take 8 anymore, right? Because otherwise it wouldn't be simple. So we must take G, and we go to 4 again. Then from 4 we can't take E again because we took it already. So we can take D, and we go to 2. From 2 we take J, and we go to 4 again. And now in 4 we can't take E or D. So we take F, for instance. We go to 5 again, and I think that we are done, right? Let's because it is closed, right? We finished in the same node that we started, and let's count the number of edges, right? We have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9 edges, right? So it's correct. This is B sub 0, and this is B9, and this is the edge number 9. Okay, so let's review everything, right? So we have this, which it is a path, right? So it's a path because for each node that we put on the path, we are able to take this vertex, right? These vertices. We have just checked that, right? That this is a path. It is closed because B0 is equals to B9, right? The starting point is equals to the end point. It is simple because there are no repeated edges. It is not elemental, right? Because there are repeated nodes like 1 and 4, 1, 4, and 5, right? 5, it is the end point, but it is also repeated in the middle of the path, right? So it is not elemental. And the length is 9. Right, so it's okay. Let's go to the next question, which is an elemental path of length 6. So all the vertices must be different, right? In this case, all the links must be different. So in this case, it's not possible because we only have 5 nodes, right? So with 5 nodes, we can't have an elemental path of length 6. So let's write it here. It is not possible because we only have 5 nodes. So if we build a path, let's say a path of length 6, it cannot be elemental, right? We must repeat at least one node. Right, so this is the answer. Okay, let's go to the next one, which is a closed and elemental path of length 2 that is not a cycle. Right, so to not have a cycle, if it is elemental, it must not be simple, right? To not be a cycle. Because the cycle, it must be elemental and simple, right? So if it is elemental, it must not be simple. So we must repeat an edge as we only must have 2 edges in the path. This means that we must pass 2 times by the same edge, right? So this is the way of building what they are asking for. So we can, for instance, start at 5, go back 5 to 1, and come back to 5 by A again, right? This is an example, but other example could be if we start in 5 and we go to 4 by E, and we come back again by E. Right, so these are 2 examples. Okay, let's write them here. So if the path was, for instance, we are starting in 5, we go to 1, and we come back to 5 by B, right? In this case, it would be a cycle, right? I let you to prove, right? I will let you do it on your own, right? To prove that this is a cycle. And the final question is a closed path, not elemental and not simple. Closed path, not elemental and not simple. Right, so in this case, what happened? Okay, let me come back here. So in this case, not being elemental, we must pass times by the same vertex. And to not being simple, we must pass 2 times by the same edge, right? And to be closed, the first vertex must be equals to the final one, right? So for instance, we can start in 5, we go to 1 by A, we come back to 5 by A, and at this point it is not simple, but it's still elemental, right? So we go to 4 and we come back to 5 again, right? So we pass 2 times by the same edge, and we pass 2 times by the same vertex, right? Which is 5. Remember that if it is on the end points, it doesn't count. So if we didn't have this 5 in the middle, it could count as only one vertex, right? But as we have 5 again in the middle, right? We have 5 in the end points that counts as 1, and we have 5 again in the middle. It counts like we are passing 2 times by the same vertex. So in this case, this path is not elemental and it is not simple. Okay, so that's all for today. Thank you for joining me. As always, if you have any question, any doubt, please don't hesitate to ask in the comments. And otherwise, I will see you in the next lecture. So bye-bye and thank you for watching.